So hi friends, let's start with Analyze Images lab. So in this lab we will understand Azure AI Vision and Azure AI Vision service, which provides us pre-built models for computer vision tasks. So including captions and tags, common object detection and people detection. So let's start. So first of all we have to go to azure.com and create our resource. So for that we will type computer vision. So when we type computer vision here, so as you can see, so this is the computer vision and this is the resource for computer vision, AI Foundry computer vision, right? So let's create this resource. So first of all we have to select our resource group. Let's select a new resource group and let's call it resource group vision. Okay, and now the region. So for this we have to select this region, like East US, East Asia, West US, and France Central. So why? Because Azure AI Vision 4.0 full features are available only in these regions. So let me select East Asia this time because East US 2 is not there. So yeah, and next the name of the resource. So the name of the resource we can say um, lab vision lab 1, right? And the pricing tier we will select free. So this is already in. Okay, so what about this? Already used, please pick a different name. Okay, so now it's working. And here you can also see the pricing details of Azure AI Vision pricing, like how it works, right? But still, we don't need to worry about this. So this is a responsible use of AI documentation for spatial analysis. So you can read this also, and then you have to check this box to review and acknowledge the all the above terms and all the responsible AI notice. Okay, right. Let's click on review and create. So it's running final validation, and yeah, so let's click on create. So everything looks fine. Subscription, resource group, and vision lab. So it is being deploying. So let's see what's are the next steps. So our next step is to go to the PowerShell, go to the classic version of PowerShell, and then um, we have to basically copy this. So we have to basically clone this repository, and after cloning the repository we have to go to this image analysis folder and activate our virtual environment. Then we have to see the we have to change the environment variable files. So like we have to change the .env files and paste our key and endpoint that we will copy from the computer vision resource. And then we have to understand this code. So this code is the main part of this lab. Yeah, so yeah, our deployment is now complete. Let's go to the resource. So in this resource we have this vision lab. So this is our resource which is in the resource group RG vision. So now if we go on to resource management, there we can see keys and endpoints. So this is the key and this is the endpoint that we have to copy paste and put it in our environment file, right? So first of all, let's open the Cloud Shell, and in the Cloud Shell we have to move to the classic version, and afterwards let's copy the first line of the code. So this is the line that we have to copy, right? So now we will paste. So this is cloned. Now we just need to go to this right? So these are the files in the folder .env image analysis.py. There is images and requirement.txt. So let's first go to images also and see what kind of. So you can see there are three kind of images: building, person, and street, right? So yeah, there are like three kind of images, and in our images folder, rest is the requirements.txt, image analysis.py, and .env file, right? Next, we have to just activate our virtual environment, and we have to install one library, which is this one, Azure AI Vision Image Analysis, and the particular version is 1.0.0. So we have to install the Azure AI Vision Image Analysis library, and we are in our virtual environment, and now it's installing the libraries. So our libraries have been installed. So let's clear the screen, and now let's go to our .env file, open this in editor. Then we have to paste our endpoint. So let's copy this and paste it here, and then copy this and paste it in our key, Control S, Control Q. Next is after doing this, we have to go to our file. So let's clear this, and let's go to our file whose name is image analysis, right? Not image, image analysis.py. So we have this. So let's uh, maximize the text editor. So we can see there are a lot of libraries we are importing. So law.env to import environment variables, right? Then there are some for plotting our image, matplotlib, pill, and then there are exception library and requests library to basically request a URL, which will be like image URL. Then we are doing this, clear the console, get configuration settings. Here we are settings our configuration, and then we are getting this image file, which is image street.jpg, and we are basically passing it in the first argument of the command line. So like when we will when we will run our program, so we will specify the image file, right? So that is what we are setting here. Now let's authenticate our Azure AI Vision client. So for that, we have to, first of all, we have to import some libraries. So as this is Azure .ai .vision dot image analysis, right? So image analysis. So first of all, what we will do, image analysis. Yes. So image analysis. So from that, we have to import image analysis, image analysis client. So we have to import this. So this is our service client that we have to import, and then we have to import azure.ai.vision.image analysis dot models. So models is a library, so we can go to the documentation of Azure image analysis. So this is our library. Let's go to the Python documentation. So in this image analysis SDK, so yeah, this is the overview. Let's go to the Python version of this. So in the overview, we have this overview in which we have sub packages AIO models and one image analysis client, right? So this is the image analysis client, analysis client, and from the model sub package. So as you can see, there is a model sub package, right? From model sub package, we will be importing this thing, visual features, visual features. And the next thing we want to import is credentials. So azure.core.credentials import key credentials. So we have to import Azure key credentials, Azure key credentials, right? So we have imported all these things here. Now the next thing that we want to do is create our client and authenticate our Azure AI Vision client. So our image analysis client, we have to authenticate that. So for that, what we will say, so we will put image analysis client, and then we have to authenticate it. So for that, first of all, we have to give the endpoint, and we are getting the endpoint here in the environment variables, that is AI endpoint, right? So we will put it here, and then we have to specify our credential. So credential, only credential and endpoint. So credential, we will use our library Azure key credentials, and then pass the credential here, which we will be getting here, AI key, right? So yeah, we will pasting this here. So that is what they have done also. So image analysis client, and this we will get a client from here. So CV client, that is computer vision client, we got it from here, image analysis client, right? So after authenticating, what is the next step? So we have to open this file. So let's do this. Let's copy this or why. So we are just opening this file. For analysis, we have to first open the file. So as you can see, we are using with, so that we can free up the resources if it comes out of the block. So we are opening this image file in read binary mode, and then we are reading the image file and putting into image data, right? Next thing, as we have the client, so now we will call analyze method on it. So in this analyze method, we will give our image data, and we will give our visual features. So let's start with CV client dot, what kind of method we want analyze method. So analyze method, and in this method we will pass, first of all, our image data, and then we will pass our features. So for features, we have to say visual features, because visual features, because we are extracting, we are telling like our client which visual features we want. Then this will be a list, and this list will be a list of enums. So we imported visual features, right? So if we see here also, if we go to visual features, so A, B, C, D, visual features, this one, right? So you can see his visual features is an enum, and then we are basically specifying which kind of enum we want. So right now in our file, this is a list visual features, and then we will use this visual features which we have imported from the dot models. And in this, what kind of functionalities we want caption, dense caption, tags, objects, and people. So first of all, we want caption, right? And then we want dense caption, dense caption, and then we want, I think, tags, and we want people, What is the next thing that we want? Objects. So we want people and objects. Objects. As you can see here also, caption is singular, dense captions, because we will be generating more than one. So that's why here captions word s is important. Tags word s is important here. Objects, because we will be it is for multiple objects. And then people, caption is only singular here, right? So that is also one thing to note. Visual features, this is all enum, so it's just a value, right? It's nothing much. So after this visual features, we provide the list, we provide our image data to our analyze method, and afterwards when we are done with this, then we have to basically get our result. So our result will be in this analyze, so this analyze method will return a result. So let's call this result, and now we will use this result. So our first code is for to display image captions and dense captions, and our next code will be analyze image function will be for tagging to get image tags. Then we will go to get objects in an image, and at last we will get people in an image. So for that uh, we have different codes. So let's first start with our caption and dense caption. Now let's understand everything logically. So here I will type some things which will make sense later. So we just need to understand the data structure of the result. So if we understand the data structure of the this result, then we can implement the each of this code in each of this task, right? So let's understand. So for image captions, so caption will include a text and a confidence code that how sure our model is that this is the text, right? So first of all, we need to think about the task. So our result will have different tasks. So we have specified these tasks that we want: caption, dense caption, tags, people, and objects. So our result will have those kind of results. So first of all, from this general result object, we might have to extract those kind of result, right? So for that, what we will do, result dot caption. It's caption because it's a single caption, right? Then result dot dense captions, because there are multiple captions, so those tasks. Then image tag, in that will be result dot tags, and then object, that would be uh, result dot objects, and then there will be people, so that would be result dot people. So all of this is coming from here only, right? So dense captions, but just everything is uh, lowercase, right? Then in captions, let's understand what will be there in captions. So in caption there will be a text, and the next thing that there will be is a confidence score, which is a float between 0 and 1 inclusive. So for that we will type confidence, right? And if we talk about the dense captions, then dense caption will be a list, right? And as it is a list, and so let's call, we have to loop on it, and let's call our iterator I, right? So for that what we will have, so for each element in the list, it will have a text, right? That will be the caption. And the next thing it will have, it will have a bounding box. So this will tell like what portion of the image the caption is for, right? So it will have this bounding box. Now let's move on, keep on moving. So result dot tags, So this will also be a list because there will be multiple tags, and because we are tagging things, then this will be also this will also we have to iterate because it is a list, right? Then what kind of things will be in tags? So text will be there in tag? No, text will not be there. Text is something that is being generated from the image. Tags are something which are like name, right? So here we will not use text, we will use name. And what else? The confidence score. So like how confident it is. So here also I just forget to mention, in dense caption also there will be one confidence score, right? So in tags also there will be one confidence, right? So now let's look at objects. So in objects will also be a list because there will be multiple objects in the image. So that's why it needs to be list. So we have to iterate on it. And then for each object, we will have a bounding box, right? So a bounding box will be there. And then what will we have? We will have a confidence score. So confidence score, and then we will have the tag. So it will have a tag I dot tag. So this tag is same as this whole tag. So for the tag also we can do I dot tag dot list, and then uh, let's call j, right? Then we will have the same thing. So I hope you're getting the point. This tag and that tag are same. So if we call I dot tag, this is basically this whole tag we are talking about, right? So yeah, this is the hierarchy for object detection. And for people also, there that would be a list because will be multiple people in an image, could be, right? So yeah, so for that also what we will have a bounding box, and we will have a confidence score. Obviously we will have a confidence score, but we will not have any tags here because we are just detecting people. We are not knowing like what kind of people. So this just for that only. We are not classifying anything. We are just detecting them, right? So yeah, these are the things. Now let's make it clear why I have done this. So for our first code, which is our image caption, right? So here you can see we have result.caption because we are talking about the caption. First of all, we are checking is it none or is it not none. So if it's none, then that means that task has not been performed. So there is nothing we can do in that case, right? Otherwise, we capture the text, like what is the text of the caption and what is the confidence score of the caption, and we multiply it by 100 because it is between 0 and 1. So person it will show in percentage like 52%, 100%. So like between 1 to 0 to 100%. So that's why we are multiplying it with 100. So let's copy this. So this is for simple caption, and for simple caption if we go here, so you can see now, like now it will make sense. We are doing nothing, we are just using result.caption, right? Checking it if it's none or not, and then we are extracting its variables result.caption.txt text and result.caption.confidence. So this is why we were doing that. Now let's delete this, and now let's move to the next question, which is dense captions. So now let's copy this and let's paste for the dense caption, right? So for the dense captions also we are checking it whether it's none or not. So if it's none, then yeah, so if it's none, then we will do nothing, otherwise we will print this. And because this is a list, that's why we are saying here result dot dense captions dot list. So we are then looping on this list with our caption variable, and then for each element we are extracting text and we are extracting confidence. So this is why we are doing this. we are extracting the text and confidence. We are not extracting the bounding box in this case, right? So yeah, so we are not extracting the bounding box in this case, right? Although there is a functionality for bounding box also, as you can see in the documentation. For dense captions we have confidence, text, and bounding box. So we are not showing the bounding box in our code, but we have the functionality. If we want to add, we can also add the bounding box here. But this is all about the captions. So this is our code. Now let's go to tags. So for the tags, let's go to the code for the tags. So for tags also we have name and confidence. Uh, okay, we have to reconnect. Yeah. So we have name and confidence. So for this result.tags.list, so we know that this is a list. First of all, we are checking is it none or not. Then because it's list, we are iterating on it, and then we are basically printing the name, not the text. Just focus on this. This is name, not text, and tag.confidence. So that is why we were uh, thinking about this in a data structured way, right? So yeah, this, this. Yeah. So now let's move to the object. So yeah, so this is for the object. Let's paste this. So in case of object, we have the tags also. So first of all, we are checking whether that object is none or not. Then we are looping on it because we know that there could be multiple objects, right? So that is why we are looping on it. And after that, what we are doing, we are printing the object tag. So for each list we have a tag also, and that tag is also a list. As we understand from here also, the tag is also a list. So whether either we can loop on it or we can index it. So here we have just index it. So tag 0 name. So this is for the first object only. So if there is only one object in the image, then it's okay. But if there are multiple objects, then we have to loop this also. But for our case, our image only has one object, so tag 0 will work. Then we are extracting the name, and then tag 0 we are extracting the confidence, right? And this is the function which is a helper function that we have created. This is just to show that the bounding box around the image. So I have added the image for this. Now let's go to people one. So let's delete this. So for the people also, we will see, it will now make sense. So here for people, we will copy this and paste it here. So let's see what we are doing here. So first of all, we are checking whether it's none or not. If it's not none, then we are looping on it because people is also a list. So for each person, we will be having a bounding box and confidence. So for confidence here, we are also checking, we are using this value. So if the confidence is greater than zero point 0.2, only then we will come inside the if statement. Otherwise, we will not even print anything. So if confidence is greater than zero point 0.2, then we will have this bounding box printed and also the confidence. So these are the two things that were there. And then this is also a helper function, show people, uh, which is used to draw the box around the person, right? Hi guys, so I ran this file, and couple of things that I want to share is here it was like I put it Azure credentials, but it was Azure credential. So that is why, yeah, that was just a small typo here. And also in this, we have to change. And besides that, when I try to run this file, so now all the file has been saved. Now let's quit this. And if I run this file with our images, in our images folder, we have street.jpg. So if I run it with street.jpg, then if I press enter, then you can see we get all the things that we printed. So for caption, we are having a man walking on leash on street, right? And it's the confidence score. For tags, we are getting the names and their confidence scores. For objects, we are getting the name and the confidence scores. And annotating objects, so it has annotated the objects with the bounding box, and the results are saved in objects.jpg, so we can check that. And then people in image, they are this is basically bounding box coordinates x, y, and wh, right? And then this is their confidence scores. So this is also people detection, object detection, right? And then this is tagging, and this is captioning. One thing which is missing is dynamic captioning. So yeah, first of all, let's check the people.jpg. Okay, failed to run an audit occurred, no such file or directory. Okay, let's try to see where this have been saved. So ls minus l minus a. So we have this people.jpg and objects.jpg, right? So to open that, so we have to download this file to our machine to basically see. So download people.jpg and download objects.jpg. So first of all, let's download people.jpg. So here, click here to download your file. Let's click here, and then this says downloaded, and then we have to download people.jpg and objects.jpg. So let's download that also. Let's see. So let's go to our downloads folder. So downloads folder, objects.jpg. So yeah, here you can see this is a person, this is the dog, taxi, and car. So this is for the object detection. For people detection, there will be just one. This is the people. So yeah, these are also the people. Even I cannot see it, but yeah, there are people here. If you can see, so this is also person, this is also person, and this is obvious. This is a person. So yeah, you have to download it to view the image, and the only thing that is left is about the dynamic captioning. So for dynamic captioning, what I observed was, so if I do this tab, image analysis.py, so I have commented this portion of my code, which is um, this dense captioning, right? And also this dense captioning here, the whole code. The reason is that when I uncomment all of this and save and control Q, so if I uncomment this and let's clear the screen for once, CLS. If I uncomment this and then I run my Python file, right, with street.jpg, so you can see here the feature dense caption is not supported in this region. So in the region in where I have created this resource, that region does not support dense captions. That is why it's not showing me. So that is why I commented that portion of the file. But for that, we do not have to do so much. We just have to change our resource. We have to delete that resource and create a new one in a new region. So that will solve the problem. Yeah, but that's the reason I changed it. And besides that, if you go, we have completed all the steps. We we will run this. We have run this command and see what are the captions, right? For different images, we could try. For this image, even for this image, we could try. And then again, we are just repeating the same steps and then testing our for different images. Yeah. So that is the whole. Yeah, that is the whole lab. Thank you.